The story of the universe begins with darkness, silence, and clouds of gas floating endlessly in space. At first glance, these clouds might seem empty and lifeless. But within them lies the power to create the brightest giants in the cosmos, stars. Every star we see in the night sky, including our very own sun, was once born from such a cloud. Scientists call these massive collections of gas and dust nebulae. Inside a nebula, gravity begins its quiet work. It slowly pulls the particles closer together, clumping them into thicker regions. Over thousands, even millions of years, the cloud grows denser and hotter. Pressure rises. The particles, once scattered across light years, now fight for space, colliding and fusing. This invisible battle marks the very beginning of a star's birth. As the center grows more compact, temperatures soar to millions of degrees. Eventually, the conditions become so extreme that nuclear fusion ignites. This is the spark of life for a star. Hydrogen atoms smash together to form helium, releasing a tremendous amount of energy. In that instant, a new star lights up, pushing back the darkness of space with brilliance that can last for billions of years. But the process doesn't just end with one star. Some nebulae give birth to entire clusters of stars, forming stellar nurseries, places where dozens or even hundreds of stars are born almost at the same time. The Orion Nebula, visible with a simple telescope, is one of the most famous of these nurseries. Looking at it is like looking back in time, watching the universe give birth in real time. The creation of stars is more than a cosmic spectacle. It is the foundation of life itself. Stars are factories, producing the elements that make up everything we know: oxygen for us to breathe, carbon for our bodies, iron for our blood. Without stars, there would be no planets, no oceans, no forests, and no people. In a very real sense, we are made of stardust. So the next time you look at the night sky, remember, every tiny sparkle is the result of an incredible journey, a journey from darkness to light, from chaos to order, the eternal birth of cosmic giants. Imagine a place in the universe where the rules of physics bend, where time slows, light disappears, and nothing can escape. That place is called a black hole, one of the most mysterious and terrifying objects in existence. For centuries, black holes were only ideas, theories written on paper. But today, thanks to powerful telescopes and advanced science, we know they are real. And they are far stranger than we ever imagined. A black hole begins its life as a massive star, one much larger than our sun. When such a star burns through all its fuel, it can no longer fight against gravity. The star collapses under its own weight, creating an explosion called a supernova. What's left behind is a core so heavy, so compact, that space itself folds inward. This collapse creates a black hole, a region where gravity is so strong that not even light, the fastest thing in the universe, can escape. At the center of a black hole lies the singularity, a point of infinite density where the known laws of physics break down. Surrounding it is the event horizon, the invisible boundary that marks the point of no return. Anything that crosses this boundary, whether it's a star, a planet, or even a beam of light, is lost forever. But black holes are not just destroyers. In fact, they shape galaxies. At the heart of nearly every galaxy, including our own Milky Way, scientists have discovered a supermassive black hole, millions or even billions of times heavier than the Sun. These cosmic monsters help hold galaxies together, influencing the movement of stars across unimaginable distances. Black holes also bend space and time. According to Einstein's theory of relativity, gravity warps spacetime, and near a black hole, this warping becomes extreme. If you could orbit close to one, time for you would pass much slower than for someone far away. To an outside observer, you would appear frozen at the edge of the black hole forever. Despite their terrifying reputation, black holes may also hold answers to the biggest mysteries of the universe. Did they connect to other dimensions? Could they be gateways to parallel worlds? Or do they mark the ultimate end of information and matter? The truth is still hidden. One thing is certain: black holes are not just monsters of destruction. They are key players in the cosmic story, guardians of secrets we are only beginning to uncover. Since the dawn of time, humans have looked at the stars and asked a simple question: are we alone? For centuries, philosophers, dreamers, and scientists have tried to answer it. And today, a new idea challenges everything we thought we knew about reality: the possibility of parallel worlds. The concept begins with the theory of the multiverse. Instead of just one universe, some scientists believe there could be countless universes, each with its own laws of physics, its own galaxies, and perhaps even its own versions of us. Imagine a world where history took a different path, where the events that shaped our lives unfolded in completely different ways. Another Earth, another you, another future. One of the most fascinating clues comes from quantum physics, the science of the very small. At the quantum level, particles don't behave in predictable ways. Instead, they exist in states of possibility, as if every outcome is happening at once. Some physicists believe this could mean that every choice we make, every yes or no, creates a new universe branching off from our own. But the multiverse isn't just a theory for scientists. It's also a question of imagination and hope. If other universes exist, could they hold intelligent life? Could civilizations far more advanced than ours be watching us, just as we look for them? Perhaps somewhere, in another dimension, a version of humanity has already solved the mysteries of space travel, disease, or even immortality. Not all parallel worlds would be like ours. Some might be wildly different, with no stars, no planets, or even no matter at all. Others could look almost identical, with small but important changes. A single event in history, a war, an invention, a discovery, might have unfolded differently, reshaping entire civilizations. Of course, the multiverse remains unproven. We cannot yet step into another universe, nor can we detect them directly. But every day, new experiments and cosmic observations bring us closer to understanding whether parallel worlds might truly exist. The question is no longer just, are we alone in the universe? But, are we alone in reality itself? Perhaps, somewhere beyond the edge of what we can see, another world is waiting, another version of us, looking at their sky, and wondering the exact same thing. When we look into the night sky, we see billions of stars, glowing galaxies, and swirling nebulae. Yet, as breathtaking as it seems, everything we can see, every star, every planet, every atom, makes up less than 5% of the universe. The rest remains invisible, untouchable, and deeply mysterious. Scientists call it dark matter and dark energy. Let's start with dark matter. Unlike normal matter, dark matter doesn't shine, reflect, or interact with light. We cannot see it directly. But we know it exists because of its powerful gravity. Galaxies spin so fast that, without dark matter, they would fly apart. It acts like a hidden glue, holding galaxies together and shaping the structure of the universe. Imagine an invisible skeleton running through space, guiding the movement of stars and galaxies. That is dark matter. But as strange as dark matter sounds, dark energy is even more puzzling. Instead of pulling things together, it pushes them apart. In the late 1990s, scientists discovered that the universe is not slowing down but actually expanding faster and faster. The force behind this acceleration is what we now call dark energy. It is as if the universe has an invisible engine, stretching space itself, making galaxies race away from each other at incredible speeds. Together, dark matter and dark energy make up about 95% of the universe, while everything we know, stars, planets, even human life, is just a tiny fraction of the whole. It's like trying to understand a giant puzzle while only seeing a small corner of it. What makes this even more fascinating is how little we know. What exactly is dark matter made of? Is it a new type of particle? Could it be connected to hidden dimensions? And what is the true nature of dark energy? Is it constant, or will it one day change and rewrite the fate of the cosmos? These questions keep scientists awake at night, searching for answers with massive telescopes, satellites, and underground detectors. Each discovery brings us closer, yet the mystery remains. Dark matter and dark energy remind us that the universe is far bigger and stranger than we can imagine. They are the invisible forces shaping our destiny, secrets waiting to be unlocked. The universe has existed for nearly 14 billion years, and during that time, it has gone through extraordinary changes. From the birth of the first stars to the formation of galaxies and planets, every step has brought us closer to where we are today. But the greatest mystery still lies ahead. What will happen to the universe in the future? One theory suggests that the universe will continue to expand forever. Ever since the Big Bang, space itself has been stretching. Not only is this expansion continuing, but it is also accelerating because of dark energy. If this continues endlessly, galaxies will drift farther apart until, billions of years from now, the night sky will go dark. Stars will burn out, leaving behind cold remnants like black dwarfs and neutron stars. In this scenario, the universe ends not with a bang, but with a slow, quiet fade into darkness, a fate scientists call the heat death. But there are other possibilities. Some scientists believe the universe might one day experience a big crunch. In this version, expansion slows and eventually reverses. Galaxies would stop racing away and instead collapse back toward each other. Stars, planets, and even space itself would be crushed together in a fiery, catastrophic end. From this destruction, perhaps a new Big Bang could occur, giving birth to another universe. There's also a third possibility, the Big Rip. If dark energy grows stronger over time, it could tear the universe apart piece by piece. First, galaxies would be ripped away from one another. Then stars and planets would be pulled apart. Finally, even atoms themselves could be destroyed, leaving nothing behind but raw energy. While these scenarios sound terrifying, it's important to remember that they exist on timescales far beyond human life. We are talking about billions, even trillions of years into the future. The Earth, the Sun, and humanity will have long since changed before the universe faces its final destiny. For now, the fate of the cosmos remains an open question. Will it drift into eternal darkness, collapse back into itself, or break apart completely? The answers lie hidden in the stars, and perhaps one day, we will uncover them. The universe has given us life, wonder, and mystery. And its future, whatever it may be, is the ultimate chapter in the greatest story ever told.